Welcome. In this video, we will learn about axiomatic system, consistency and completeness. These concepts form the foundation of modern logic and mathematics. By the end of this lesson, you will understand how logical systems are built and why they must be both reliable and meaningful. Let's begin with the idea of an axiomatic system. An axiomatic system is a method of building knowledge using a small set of basic assumptions called axioms. From this starting point, we use logical reasoning to drive many new statements. Think of it like building a house. The axioms are the foundation, and every conclusion is built on top of them. Without clear starting point, logical reasoning can become confusing or inconsistent. An axiomatic system provides a structured framework where every conclusion can be checked step by step. This makes reasoning clear, organized and reliable in subjects like mathematics, computer science and formal logic. An axiom is a statement that is accepted as true without requiring proof within a particular system. It acts as the starting point for all further reasoning. Axioms are not chosen randomly. They are carefully selected because they help build a consistent and useful logical framework. Imagine a single geometry system where we accept the statement through any two distinct points there is exactly one straight line. This is treated as an axiom. From this single assumption, many geometric rules and theorems can be logically developed. Good axioms should be clear, simple and free from contradiction. They should also be independent, meaning one axiom should not be provable from another. Together, these qualities help create a strong and dependable logical system. Once we have axioms, we need a way to reach new conclusions. This is where rules of inference come in. These are logical rules that tell us how to move from one true statement to another valid conclusion. They are the tools that make logical reasoning possible. A famous rule of inference is Modus Ponens. If A, then B is true, and A is true, then B must also be true. This rule is widely used in mathematics, logic, programming, and everyday reasoning. Rules of inference ensuring that every new conclusion follow logically from previous statement. They prevent random guessing and keep reasoning valid. Even with perfect axiom, we cannot build a logical system without proper inference rules. A formal system is a complete logical framework made up of symbols, axioms, rules of inference, and precise rule for writing valid expression. Everything follows clearly defined procedures, leaving no room for ambiguity or personal interpretation. A formal system has four main parts: a set of symbols, a set of axioms, rule for forming valid expression, rules of inference for driving conclusion. Together, these components allow us to prove theorems in a systematic and reliable way. Formal systems are used in many fields. They form the basic of mathematics, computer programming, artificial intelligence, digital circle design, and automated theorem proving. Whenever computers perform logical operations, they rely on principles of formal system. So far, we have learned how logical systems are built. But building a system is not enough. We must also ask an important question. Is the system reliable? To answer this, we study two important properties: consistency and completeness. A logical system is consistent if it never proves both a statement and its opposite at the same time. In other words, contradictions are impossible. A consistent system gives us confidence that its conclusion can be trusted. If contradiction exists, then logical reasoning breaks down. Once a system allows both a statement and its opposite to be true, this makes the entire system unreliable. Therefore, consistency is essential for meaningful reasoning. A logical system is complete if every statement that is actually true within the system can be proved using its axioms and rules of inference. A complete system leaves no true statement permanently unprovable. Completeness ensures that the system is powerful enough to answer every valid question within its scope. If a system is incomplete, some true statement may remain beyond its ability to prove, limiting its usefulness. Consistency and completeness are closely related, but they are different concepts. Consistency focuses on avoiding contradiction, while completeness focuses on proving all true statements. A good logical system aims for both, although achieving both together can be difficult in a very powerful system. The mathematician Kurt Gödel made a groundbreaking discovery. He showed that in sufficiently powerful mathematical system, it is impossible to achieve both perfect consistency and perfect completeness at the same time. This result changed the foundation of mathematical logic forever. Consistency and completeness help us evaluate the strength and reliability of logical systems. They are fundamental concepts in mathematics, philosophy, computer science, artificial intelligence, and formal reasoning. Understanding them help us appreciate both the power and the limit of logical thinking. If you are still watching, I hope you are finding this content useful. Please like and share this video. Subscribe to the channel and share your thought in the comment. Your support motivates me to create even more content like this.